Hello everyone, welcome you in my YouTube channel. I am Dr. Mohammad Sirajul Faisi. Today in this video, I am going to talk about iterations. So first I will talk about the substrates. Is primary halides, base high concentration of a strong base, and solvent aprotic polar solvents. This is the conditions. Base, what type of base you need? You need high concentration of a strong base and aprotic polar solvents. Now even reactions, the reactions and mechanism, kinetic, stereochemistry, reduced selectivity, carbocation rearrangement. So I will discuss one by one reactions and mechanism, kinetic, stereochemistry, reduced selectivity, carbocation rearrangement. So reaction and mechanisms. The even reactions, here is your substrates, 2-bromo 2-methyl propane react with water forming 2-methyl propene. This is double bond here. So even reaction like this SN1 reactions involve carbocations intermediate. You see, this is tertiary carbon. Why it is tertiary? Because it is bonded with the 3 carbon. So alkyl halide dissociate forming a carbocation. So this is the formation of carbocation. And then the base remove a proton from a beta carbon. This is beta carbon, and forming these products. So look at from here to here, all the formations of double bonds. What is the kinetics? The kinetics, the rate of reaction is equal to K, concentration of alkyl halide. And this is a unimolecular reactions. Stereochemistry, even elimination from cyclic compounds. This is not an axial positions. So basis of methanol, even conditions, it form carbocation here, and then eliminations occurs and forming this product. No axial orientation required for the even reactions. So orientation is important. No axial orientations required for even reactions. Now reduced selectivity of even reactions. The major product in the even reaction is generally the more substituent alkene. So look at here, this Cl forming 2-methyl 2-butene major product and 2-methyl 1-butene minor product. So here double bonds and here double bonds. So if here is double bond, then we call this minor product. If here is double bond, then we call is major products. Now stereochemistry of even reactions. Both syn and anti-elimination can occur in an even reactions. So this is beta carbon has 1 hydrogens. This forming this carbocation, and now there is a major product formation of double bond here, and here this is the minor products double bond. So the major stereoisomers obtained from an even reaction is the alkene, in which the bulkiest substituents are on opposite side of the double bond. Now reactions coordinate diagram for the even reaction of 2-chloro 2-methyl butanes. So look at here, this is the Cl. and this is the carbocation, and these are two products. One product is one position double bond less substituents, and here double bond more substituents. So this is the more stable and this is the less stable. Now carbocation rearrangement. So because of the even reactions forms a carbocation intermediate, we need to consider carbocation rearrangement. This is 3-chloro-2-methyl 2-phenylbutane. This is methanol, forming this carbocation and 1,2-methyl shifts and forming tertiary benzylic cation, and then elimination occurs and forming this more substituted products. In case of this, you see formation of this carbocation, again 1,2 hydride shift and forming secondary allylic cation and 1,3-pentadiene. Now another example is 1-bromo-2,3-dimethyl cyclohexane. So look at in these substrates, this is the axial equatorial positions. After even condition forming carbocation here and the transfer of 1,2 hydride shift forming this carbocation here, and this is the tertiary and the formation of these double bonds. This is very important reactions for exam, gate and NET examination. Now because the first step is the rate determining step, the rate of an even reaction depends both on the easy with which the carbocation is formed and how readily the leaving group leaves. So reactivities of alkyl halide in an even reaction, relative stabilities of carbocation. So 3-degree benzylic, approximately 3-degree allylic, greater than 2-degree benzylic, 2-degree allylic, then 3-degree, 1-degree benzylic, 1-degree allylic, 2-degree, 1-degree and vinyl. Least step. So just think about the big range. Here vinyl or here 3-degree benzyl. So relative reactivities of alkyl halide in even reaction is RF least reactive and alkyl halide most reactive. Now competition between E2 and even reactions. Primary alkyl give only E2, secondary alkyl halide E1 and E2, tertiary alkyl halide E1 and E2. And E2 is favored by high concentration of a strong base and an aprotic solvent, and E1 is favored by weak base and protic solvent. This is very important. Just remember, E2 high concentration, strong base, E1 weak base and protic solvent. Now competition between substitution and eliminations. Alkyl halide can undergo SN2, SN1, E1 and E2 and E1. Decide whether the reaction condition favor SN2 or E2, SN1, E1. SN2, E2 reactions are favored by high concentration of a good nucleophile strong base. SN1, E1 reaction are favored by poor nucleophile weak base. Decide how much of the product will be substitution product and how much of the product will be the elimination product. So this is the table for comparisons. Summary of the products expected in substitution and elimination reactions. Primary alkyl halide, primary substitutions unless there is a steric hindrance in the alkyl halide or nucleophile in which easy elimination is favored, cannot undergo SN1 E1 reaction. Secondary alkyl halide, both substitutions and elimination. Both substitution and elimination, the stronger and the bulkier the base, the higher the temperature, the greater the percentage of elimination. Tertiary alkyl halide, only eliminations, both substitution and elimination. Now, stoichiochemistry of substitution and elimination reactions. SN1 Both stereoisomers RNAs are formed more inverted than retained. In even both E and Z stereoisomer form more of the stereoisomers with the bulkiest group on opposite side of double bonds. SN2 only the inverted product is formed. And even both E and Z stereoisomer are formed more of the stereoisomers with the bulkiest group on opposite side of the double bond, unless the beta carbon of the reactant is bonded to only one hydrogen, in which case only one stereoisomer is formed. Its configuration depends on the configurations of the reactants. Now, a bulkier alkyl halide or sterically hindered nucleophile encourage elimination over substitutions. So look at the primary alkyl halide is sterically hindered and forming 1-methoxy, 2-methylpropane, and then this double bond. So this is the 60%. So substitution and elimination. Now here is your group 50% and you see 85% elimination. So it depends on the substrate molecules also. Now a strong, bulky base encourage elimination over substitution. You see, this is the chlorine and this is the strong base favor the elimination products. So 25% and 75% you favor the elimination. Here is acetate ion, you see isopropyl acetate, additions products, so I mean substitution products. A weak base favor the substitution product. Now tertiary alkyl halide undergo elimination reactions under SN2 or E2 conditions. Look at here, and this is the base forming 100% eliminations. Now high temperature favor elimination over substitutions. 45 degrees Celsius, you see 50%, and 100 degrees Celsius 71%. Why? Because elimination is entropically favored. Synthesis example, you see HBr and you see target molecules. Now another synthesis example, racemate, you see the formation elimination products and then it gives the target molecule. Another examples, retrosynthesis here, how the cyclization occurs. This is elimination products and this is the target molecule. Now E2 reaction should be used if you want to synthesize an alkene. So SN2E1 condition hydroxide, formation of double bond, here formation of double bond and substitutions. Consecutive AT eliminations reactions require a strong base, sodium amide reactions carried out in liquid ammonia. You see, formation of alkyne, formation of double bonds. So friends, hope this video will be helpful to you. If you like this video, then subscribe my channel and thanks for watching.